there is a sender, and there is a receiver. Okay, in order to handle the flow control, so TCP uses two windows. So one is send window, one is receive window. Can anybody tell me from the previous last class discussion at the sender side, so what window I need to maintain in order to maintain the flow, and at the receiver end, what window I need to maintain as a part of maintaining the flow control. At the sender end and receiver end, out of the send window and receive window, what windows we need to try to understood. So not only at the sender end, I need not to only maintain send window, I need not to maintain receive window at the receiver end. Rather than, and last class I have discussed, at the sender end, I need to maintain both the window, send window and receive window. So at the receiver end also I need to maintain send window and receive window. Let's say I maintain a send window and receive window only at the sender and receiver. Then sender can send data. Try to understand this concept very, very clearly. Receiver can send an ACK. Not a problem at all. Sender can go and send any amount of data. Accordingly, receiver can send an ACK, and accordingly, sender can go and send next amount of data. There is no problem absolutely. So when a sender, so at the sender end, I maintain the send window, and at the receiver end, I maintain the receive window only. But if I did not maintain this, now let's say it may happen. Say receiver wants to send some data, may happen ना, ऐसे नहीं कि sender सब data भेजेगा, बस sender ही भेजेगा, receiver बस ACK भेजेगा, ऐसे तो नहीं है ना. So whenever it is a sender and receiver communication, there will be always a bidirectional communication. Sender must send, receiver must receive. So receiver must send, sender must receive data. So that's why whenever the receiver wants to send some data, if he did not maintain a send window, can he able to do so? No. If so, the sender does not maintain the receive window. So then can he receive the data? No. Try to understood. So only, so if I'm maintaining a send window at the sender end, receive window at the receiver end, then only a one directional communication can happen, that is from sender to receiver. No bidirectional communication can happen between the sender and receiver. So if I want a bidirectional communication between the sender and the receiver, then both must maintain send window as well as receive window at both the ends. Size, unless until he knows what is the receive window capability of the other end. That means if the receive window of the receiver is 800, so then only accordingly I set it as 800. It cannot set it independently. So send window is set so based on the receive window capability of the other end. Very, very important. So every line what I'm saying, every word what I'm saying is very, very so important to understand. So based on the receive window capability, the send window is going to set its own size. So that is by the other end. Okay, similarly, so if I want to set the send window at the receiver, then I must know what is the receive window at the sender. If it is 1000, so then only I set it to 1000. That means this send window depends on this receive window, this send window depends on this receive window. That means send window is set based on the capability of the other end of the receive window size. Okay, that is what is the concept what we discussed in the last class. Very, very important concept we have to discuss. Okay, now let's in today's class, let's try to understand what is the problem. So even if we have done all these things, there is a problem associated here. Okay, there is a problem associated. Let's look into what is the problem I talked about. Okay, let's look into the problem. This is my sender, this is my receiver. Okay, so now what is happening? Sender maintains a send window. Let's say I'm talking about one directional communication. If it is a one directional communication, sender needs to maintain a send window and receiver needs to maintain a receive window. If there is no bidirectional communication, let's assume there is a one directional communication. So as far as my scenario for problematic scenario is concerned. Now what is happening? Let's say the sender is sending 1 byte of data. 1 byte of data. Okay. Continuously the sender is generating 1 byte of data. 1 byte of data. Okay, so when the sender is so when I say sender is sending 1 byte of data, that means it is a data, 1 byte of data. So whenever 1 byte of data is going, so as a part of transport layer header, minimum how many bytes of header? Again, going ahead, so network layer is going to add its own header. And if you you have not known this at this point of time, but let me tell. So in the network layer header also minimum 20 bytes of header is going to add it. Minimum. Again, it can go up to 60 bytes exactly as TCP. Okay. So that means minimum 20 bytes of header is added as a part of transport layer header. minimum 20 bytes of header is added as a part of network layer header. Other layer के बारे में भूल जाइए, ये दोनों layer को हम सोचेंगे. So तो क्या होता है, let's see. Okay, that means, so if I look into these two layers only, so for sending only 1 byte of data, I have to add 40 bytes of header. Okay, as a consequence of it, in total 41 bytes of total data is going in this particular packet. Okay, but out of this, how much byte of data is there? Only one. Okay, similarly for the next chunk, for sending 1 byte, I'm sending in total 41 bytes. For the third also, so it is 41 bytes in total. Can anybody think of, is it seeming to be any problem or not? If I look into this, so it does go and send very less amount of data. As a consequence of lot of headers is going to add, so this is going to occur, or this is going to create lot of overhead on the network, thereby the bandwidth bandwidth utilization of the network is very, very poor in that case. Because of sending 1 byte of data, I'm sending 41 bytes of ultimatum data, including my headers. So this is a very serious problem as far as overhead in the network is concerned. Okay, and why it is happening? Why it is happening? Because my application layer. Why it is happening? Because my application layer is generating the data slowly, very slowly. What happens? So why I am sending 1 byte of data? Because my application is, let's say, generating 1 byte of data in 1 second. So as a sender, what I can do? I have to send that 1 byte of data to the other end. So that's why. So as my application layer, so when my application layer is going to generate the data very slowly, as a consequence of it, it may happen I have to send very less amount of data. As a on top of it, so more amount of headers is going to added. So which is going to incur overhead on the network. Okay, so as a consequence of it, so this seems to be a problematic scenario for me. Okay, and this happens due to whom? So as the sender is generating, that means, so the first problem that I talked about, so it is happening because of the sender generates data very slowly. Why this problem is arising? Because the sender is generating the data very slowly. That is why the reason. So why this problem is arising. Let's look into another scenario. Okay, so let's talk about the receiver. Let's say the receiver has a capability of 4 KB. मान के चलिए receiver has a capability of 4 KB. And the sender generates data at the speed of 1 KB per second. Okay, so 1 KB of data is generating at one point of time. So as a consequence of it, क्या होगा? So he's going to send 1 KB of data. He's going to send 1 KB of data. If he's sending 1 KB of data, if I assume the same header, so 40 bytes of header, 1 KB में 40 bytes doesn't make much sense. Okay, so maybe the overhead. If I look into the overhead, यहाँ पर कितना overhead होगा? So total bytes of data is 1040 by 1040 by 1000. So if I calculate this overhead is much less than this overhead. Okay, so that's why the overhead is very, very less. So because the application layer is generating the data very fast. So 1 KB of data, so at a point of time is a good enough. Okay, so now in that case, if I look into 1 KB of data is going, 40 bytes of header is going. Now let's say, so now come and store in the buffer. Yeah, so sender has sent it, receiver has received it, and it comes and stored in the buffer. So then the sender has sent another 1 KB of data, let's say. क्योंकि उसके पास 4 KB का बफर है ना, 4 KB का बफर, जब तक बफर नहीं फुल हुआ है, you can go and send the data. So another 1 KB of data is sending. So then another 1 KB of data is coming and sitting in the buffer. Then another 1 KB of data is sending. So coming and sitting in the buffer. So then another 1 KB of data is coming and sitting in the buffer. Now the buffer at the receiver end is full. Once the buffer is the receiving end at the full, can anybody tell me what will be the receive window? That is, so receiver, the receiver end, so it may occupies the whole buffer, so my receive window becomes 0. Now the question is, so once the buffer is full, so when the buffer is going to free, can anybody tell me from the last class discussion? When my application layer who is sitting above the transport layer, because who maintains the send window and receive window? Who maintains? Application layer or transport layer? Who maintains the send window? 1 byte. So because 1 byte of memory is free, so whenever 1 byte of data is consumed by the application layer, that memory space in the buffer becomes free. So as a result, my receive window becomes 1 byte. Okay, so when my receive window becomes 1 byte, as a consequence of it, let's say it advertise the arc with the receive window size of 1. When it advertise the window with a receive window size of 1, arc with a receive window size of 1, so what the sender is going to do is but due to the restriction of the receiver, so he cannot go and so even if he generate 1 KB of data, but he cannot send 1 KB of data, he can send only 1 byte of data. If he is again going to send 1 byte of data, as a consequence of it, 40 bytes of data is added. Again the same problem. This time, so the same problem has arisen because of the receiver. So that's why the second scenario is the same problem can arise because of the receiver. Why it is? Because the receiver is consuming data very slowly. So that means, so this problem what I talked about can be generated so due to two reasons. The first reason is either the sender is generating the data slowly, the same problem can arise, or it may happen the receiver can go and consume the data very slowly, also the same problem is going to arise. So that problem is basically called as a silly window syndrome problem. This problem what we discuss right now, so this technically called as a silly window syndrome problem. This problem what we discuss right now is called as a silly window syndrome problem. That means the silly window syndrome problem can be generated so due to a sender, or it may be generated so because of a receiver. Okay, now next question. Once the silly window syndrome problem is there, we have to get rid of it. So what is the solution as far as this silly window syndrome problem is concerned? Okay, let's look into this. Okay, now let's look into this silly window syndrome problem and what is the solution of it as far as sender is concerned. So go one by one. We'll go for the sender first. Due to the sender, whatever silly window syndrome problem we discuss, whatever arises, how to get rid of this problem. Okay, now let's look into this scenario. This is the sender. This is the receiver. Okay, so let's say sender has a buffer send window of 4 KB. Okay, now what I'm saying, application layer. So at the sender end, if I look into at the top, there is the application layer, then the transport layer. Okay, and transport layer maintains this particular buffer. Okay, so application layer now generates 1 byte of data. So now application layer, after generating the message, give it to whom? Give it to the transport layer. So as far as our communication is concerned, application layer generates the message, give it to the transport layer, so for further communication. So now when the message is generated and given to the transport layer, so now what the transport layer is doing? So bringing the message and putting in the buffer. Try to understand the sequence I am telling. So application layer generates 1 byte of message. So now it is giving to the transport layer for sending to the other end. So now transport layer is what it is doing, it is going to keep the data in the buffer. Now the next question is, whenever it is going to keep the data in the buffer, okay, so it may happen, so instead of sending the data to the network, because it is the responsibility of the transport layer, whenever you are generating a message and sending it to the transport layer, as far as TCP is concerned, if you remember, it is not guaranteed that your data is going to send immediately. It depends on the transport layer. Transport layer will take a decision whether to send the data immediately or not. If I'm going to send this data immediately, already we see the problem. If I go and send the data immediately, 1 byte of data in the network, so then 40 bytes of header is going to added. As a consequence of it, overhead in the network is going to increase. That's why what TCP is going to do, it is not going to send the data. So rather it is going to keep the data in the buffer for some period of time. Kitna time ke liye rakhega abhi bolenge. Okay, so now another 1 byte of data is generated. Another 1 byte of data is generated and sent to the transport layer again. So it is going to kept in the buffer. Okay, again another 1 byte of data is going to generated and kept in the buffer. Like this it is going to continue. Okay, so till what? Now the question is till what? So my buffer is going to populate with this data rather than sending. Only the buffer is populated rather than sending the data. So that's why, so there is 2 points. The first point is till the buffer is filled with 1 MSS. Very important point, everybody look into. So So my transport layer is accumulating the data in the buffer till the buffer is filled with one MSS. What is MSS? MSS is maximum segment size. Try to understood what is the maximum segment size and what is the requirement of it, why it is required. Okay, so what I said, can anybody tell me, to answer this question, what is the maximum segment size? Let me ask you a question. Can anybody say, is there any restriction regarding generation of data by application layer towards the transport layer? So whenever application layer is going to generate a data towards the transport layer, is there any restriction, or so application layer can generate as much of data as much? So now the next question is, so let's say so buffer is 4 KB. Okay, if the buffer is 4 KB, do you think that is it always possible to go and so send 4 KB of data in the network? Do you think that even if my buffer size is 4 KB, so can I go and send a packet of 4 KB into the network and it is going to go? See, it may not. It may not. It may not. It may not. So try to understand why I'm saying it is may not. Whenever I'll talk about the data link layer, it will be 100% understood. But for the time being, I'll only just tell me. So whenever the data is going to send over the network, finally the data has to send over whom? NIC card. अरे डेटा अगर मेरा मशीन से बाहर को जाएगा, नेटवर्क को जाएगा, तो क्या करेगा? अल्टीमेटली माय डेटा हैज टू कम आउट ऑफ माय NIC card, my system, so to the communication link. But whenever you are going to send your data on top of a communication link, I mean from the network card to the communication link, a network card has a physical capability. Okay, so let's say my network card, NIC card capability is to take a maximum of so packet of 1500 bytes. So whenever data link layer हम पढ़ेंगे, आप उसको पूरी तरह से समझेंगे. अभी just to so give a overview, I am telling. NIC card capability is to take only maximum of 105,000 bytes of data at a time. एक बार में वो 1,500 data packet can send to the network. Okay, that is what is the capability of it. So in that case, even if my buffer size is 4 KB, I can't send a packet of 4 KB into the network. So that's why, so we need to fragment the packet. We need to divide the packet. We need to divide the 4 KB packet into fragments of 1500 bytes. So that is called fragmentation. So fragmentation happens at the network layer, but we will not going to talk about at this point of time. But we have to understood, if so my NIC card capability is 1500, so at the transport layer itself, based on this NIC card capability, I have to divide the packet. I have to divide the packets, and that is called as segmentation. Segmentation. That means, so even if my application layer is generating a 4 KB of data, so because my size of the buffer is 4 KB, but I cannot send a 4 KB of packet to the network. I cannot send a 4 KB of packet to the network. Rather, I can send a packet of so maximum segment size into the network. So what is the maximum size segment size? So maximum segment size is telling what is the maximum size of data can be present in a data or present in a packet. So when a packet is sent to the network. So if I say my maximum segment size is, let's say 800. Let's say for example, if I say my maximum segment size is 800, that means so I can send a packet which carry 800 bytes of data into the network in one go. Okay, in one go, I can send a packet of maximum 800 bytes, not more than that. So that's why, because my maximum segment size is 800, and by default, remember this concept also. So by default, as far as TCP is concerned, the maximum segment size in TCP, that is MSS, in case of TCP by default, it is 536 bytes. Okay, this is the default MSS value for TCP, that is 536 byte. If you want, you can change it, you can increase it, you can decrease it, but this is the default size. So as this is the default size, if I go by the default size, so that means I can go and send a packet maximum of 556 bytes of data plus 40 bytes of header. If I think like that, so 20 bytes of transport layer header, 20 bytes of network layer header. So then I can say 576 bytes. So my size of the whole packet, including my transport layer header and network layer header, can be of 576 bytes. That can go in one time. So that's why. So whenever you are going to send the packet to the transport layer, whenever transport layer is keeping your packets in the buffer till what it is going to, so keep the buffer till one MSS is full. Why? Because if data is full with one MSS, now he can go and send to the other end. And if I assume my MSS is 536, so this is a good value. So where my overhead is not so high. So that's why I can go and send the data at this point of time. So this is the first condition where the data is going to send to the other end. So instead of sending the data immediately to the other end, if the application layer is generating the data slowly at this point of time, what the sender is going to do? Transport layer of the sender is going to accumulate the data in the buffer, and once the buffer is filled with one MSS, so then that data is going to fill. So if that is that problem going to generate a packet or send the packet. So when the sender, I'm talking about sender, receiver के पास ये लिख रहा हूँ because of space, no, not availability of space, but it's about the sender. So when the sender receives an ARC, on behalf of earlier sent packets. Okay, so let's say, so now I am accumulating these packets because of the application layer is generating the data very slowly. It has not filled with one MSS. MSS का size मान के चलिए 536, but till now I have accumulated 200 bytes of data. Till now, so in the buffer there are 200 bytes of data, but in the meantime I receive an ARC from the other end. Okay, so I have accumulated in the buffer 200 bytes of data. Okay, so in the meantime I have received an ARC on behalf of the earlier sent packets, okay, which I have already sent. So and I receive an ARC on behalf of that. In that case, I will not wait for one MSS to be filled. So rather I'll go and send the data whatever is filled at this moment. So that's why whatever is filled, let's say 200 kbps, so or 200 bytes, not kbps, so 200 bytes. So now I'm going to send 200 plus 40 bytes of data to the other end. These are the two scenarios when my data can be sent to the other end. So otherwise I have to go and keep the data in the buffer till one of the condition is going to fill. Okay, and these 2 points what I discussed is nothing but a part of a well-known algorithm, so that is called as a Nagel's algorithm, if anybody hears about it. Nagel's algorithm, very well-known popular algorithm. So that means, so Nagel is the person who finds an elegant solution for the silly window syndrome problem. So that is arise out of the sender, and what the solution he has provided, these are the 2 solutions he has provided. That means you go and accumulate the data in the buffer, so till the buffer is filled with one MSS or an ARC is received from the other end. At that moment only you send the data to the other end. Otherwise you go and populate the buffer, so without sending the data to the other end, thereby taking care of this overhead problem that is arising because the sender is generating the data very slowly. Everybody understood, or anybody has any doubt on top of the sender problem, you please tell me. Whatever problem we discussed already, how to get rid of that problem. Okay, so now to understand the receiver, let me draw the diagram so that we can explain accordingly. This is my sender, this is my receiver. Okay, so see, this is the sender buffer, this is the receiver buffer. Okay, now what I'm saying, when the receiver side problem is going to arise, if let's say the buffer is full, buffer is already full, and now the receiver application is consuming the data, okay, very slowly. The receiver application is consuming the data slowly from the buffer, then this kind of problem is going to arise. Okay, original scenario mein boliye. So then now the let's say buffer is full, at the time receive window is 0, already everybody knows it. Okay, so when the receive buffer is full, there is no more space available to receive any more data. Now the receive window is 0. Original case mein kya hoga? It is going to send an ARC. Yes, it is going to send an ARC with a receive window of 0. Yes, correct. Now yes, after this what happens, let's say 1 byte of data is consumed. 1 byte of data is consumed by the application layer. So at that moment, receive window becomes 1. If the receive window becomes 1 in the original scenario, so it is going to send an arc with a receive window of 1. Yes. If it is going to send a receive window of 1, so this is the reason why the problem arises. As it advertises a receive window of 1, that means now sender can go and send 1 byte of data. Sender can send 1 byte of data. As a consequence of 40 bytes of header is added. Again, the same problem arises because of this. So what the receiver is saying, what the solution for the Clark solution as far as the receiver problem is concerned. So the first, so it tells, okay, you go and advertise an arc, but with a receiver size of 0, even if it is 1 byte. Okay, you go and advertise an arc with receiver window size of 0, even if some space is available. Space is available. Okay, now what he's saying, even if it is receiver window is 1, so in the solution, what he's saying, you don't do this. You don't do this because the same problem is going to arise. Rather, it's going to generate an arc with a receiver window of 0. Even if the receive window size is actually 1, but still you go and advertise the window size as 0. Again, so now another 1 byte is consumed. Receiver window becomes 2. Again, you go and advertise an arc with a receiver window of 0. Not 1, not 2. You go and advertise the receiver window as 0. Okay. Now, if you go and do this, sender cannot go and send 1 by 2 byte data. Na? If sender cannot go and send 1 by 2 byte data, so obviously my problem is solved. But now the question is, till what it is going to do? Kab tak ye karte rahenge? That is the next question I have to answer. Okay. So till what? So we have to go and advertise the receiver window as 0, even if there is some space available in the receive window size. So there are two conditions we have to understood here. There are two conditions. So we have to understood till what we are going to do it. So now see, so aise karte a time will come, it may happen if my receiver window is 4 KB. Okay, so now 2 KB of data is filled. Okay, or let's say my MSS is 1 KB. Let's think like this. MSS is 1 KB. Okay, MSS is 1 KB means, so now what happens? So doing this continuously, if application layer is going to consume the data continuously, a time will come, so when 1 KB of space will be available. Okay, and still 3 KB of data will be there. Okay, if that is going to happen, so then, so at that point of time, so I should not advertise a arc with a receive window of 0, rather we should advertise a receive window of 1 KB. That means what I'm saying, so when at the receiver buffer, so free space available becomes 1 MSS, so then I should advertise the actual window size. That means, so till 1 MSS buffer is freed. Okay, so till what I have to advertise the window size from the receiver end to the sender end as 0, till 1 MSS buffer size is freed at the receiver. So once 1 MSS buffer is free, immediately I should advertise the actual window size. And then, so if the sender is going to send, so it is going to send a packet of 1 KB, so that is the MSS size. So that's why, so that problem is no more going to arise. So this is one scenario. Second scenario, another scenario he's also telling, till what the so you have to go and send. Now let's say my MSS is 3 KB. Another scenario I'm giving. So my MSS is not 1 KB. My MSS is 3 KB. My buffer is 4 KB. At that point of time, what is saying another scenario? So now let's say out of 4 KB, 2 KB of data is packed, 2 KB becomes free. Till my MSS is not reached. My MSS is 3 KB. So, but my available space is 2 KB. So in this scenario also, I could able to send the, arc, actual arc. That is what is the condition? Till buffer is half freed. That means if either of this condition is encountering, so then I have to go and send an ACK on behalf of read, so that sender can go and send the data. So what are the two conditions? Once again, I'm repeating. Either one MSS so value is free in the buffer, or the buffer is half freed. Out of 4 KB, 2 KB is free, 2 KB is free. In that case also, I should advertise the window size to the other end. So thereby, so the sender is going to send a so large enough data, fair enough data, so from the sender end. So thereby, so taking care of this overhead problem, and that problem will be no more. So that's why, so this solution is provided by Clark. So this is called as a Clark's solution. Clark's solution. As far as the receiving end is concerned, so the solution, whatever I discussed right now, so that is provided by Clark, and it is called as a Clark solution. Okay, and another solution has been also provided. So in this case, what happens? Every time I am advertising an window, जब कोई भी मतलब मेरा receive window size change हो रहा है, whenever the receiver window size is changed, I have to generate an ACK. Okay, saying what is a new receive window size. But always I am going to advertise the receive window size as 0 unless until my receiver buffer is not freed with one MSS or half freed. But if I look into this, so there are some ACKs I'm sending. Lot of ACK packets as a consequence I'm going to send, which may consume the bandwidth or increase the traffic in the network. If I try to understand what is the disadvantage of this, if I look into so this Clark solution, what is the main disadvantage of this Clark solution? What is the main disadvantage?
So a lot of unwanted acknowledgements.
Yes, I mean lot of traffic. Lot of ACK packets needs to be sent. Lot of traffic is going from the receiver to sender in the form of ACK. Because every time, so as the receiver is consuming the data very slowly, every time there is going to be a change in the receiving window, ACK has to be sent. Okay, so a lot of traffic is going to so increase in the network, so as a part of sending the ACK. So that is a disadvantage of this particular first solution of Clark. So that's why another solution comes into picture. So that is called as a second solution, that is called as a delayed ACK. Delayed ACK. What the second solution is telling? So look into the same scenario. What the second solution is telling? This is my sender, this is my receiver. So let's say buffer is filled at this moment. Okay, so now what happens? So 1 byte of data is consumed, so 1 byte becomes free. Okay, if 1 byte of data is freed, previously kya kar rahe the? We are sending an ACK with a receive window size of 1. But in this case, even if the receiver size is 1, I did not send an ACK. I will not send an ACK. Rather, I will wait for some time. Okay, I will not delay ACK means I will not send an ACK. I will delay the sending of an ACK. That is why it is called as a delayed ACK. So I will not go and send an ACK. Rather, I will wait for some time. Okay. Now the question is, so whenever I am going to delay it for certain time, okay, I will not send this ACK. Okay. So then what is the advantage? First advantage is going to get. What is the advantage first? Reduce the traffic. Reduce traffic. The first problem we discussed in case of Clark's first solution, so that is taken care of. We are not sending unnecessarily ACKs, but so there is a disadvantage of it. Can anybody think of? Can anybody think of what is the disadvantage of it? What is the disadvantage of Clark's solution? To retransmit the data once the timeout occurs. Once the timeout occurs, I have to go and retransmit the same data. Retransmit. So, but this data is already received. Why it is not sending the ACK? Because to handle I mean the silly window syndrome problem. It is not that ACK is lost. It is not generating the data or ACK because to handle the silly window syndrome problem. But if I go and delay the ACK, so then it may happen a timeout is going to occur and the retransmission is going to occur at that point of time. So that's why what is the disadvantage we understood out of it? The disadvantage is that it may result in sending unnecessary retransmission. Unnecessary retransmission. Getting my point? So due to this delayed ACK, it may happen. So as a result of delayed ACK, unnecessary retransmission is going to happen. So whatever packet is already received, my sender is going to retransmit those packets. So in order to make a balance between this advantage and disadvantage, what the delayed arc is saying. So now the question is, till what I have to delay the arc? कितना सा time तक मैं arc को delay कर सकता हूँ? So that means, so there is a solution provided in order to handle this scenario. So that is saying that the implementation, current implementation is saying you cannot delay arc, cannot delay sending of an arc beyond 500 millisecond. That means, so whenever my buffer is being freed, let's say receive window becomes 1, receive window becomes 2, receive window becomes 100. Sure, that means once, so my 500 millisecond times is elapsed at the receiver window. Receiver end में, so जब मैं, so not sending an arc, so after that if 500 milliseconds have been elapsed and I have not sent an arc, then I have to send an arc. I have to send an arc before that. So once the 500 milliseconds time is elapsed, even if my receive window size is small, I have to go and so advertise it. Otherwise, so the problem of again retransmission is going to come. So that's why within 500 milliseconds, it has been calculated that my window size will be sufficient enough, even if my receiver is accumulating the data very slowly, so that sender can send decent amount of data, so without encountering into much overhead, so thereby handling the, so what? So silly window syndrome problem. So this is what, so how, so the receiver end can take care of the silly window syndrome problem, so to handle the overhead problem that is happening due to it. So this is, so at the sender side, so Nagel's algorithm is being used, and at the receiving side, okay, so let's say my MSS value is 1 KB. My application is generating, let's say 4 KB packet, a packet of 4 KB. Okay, so now let me give the scenario below so that I can able to explain you more properly. Okay, now let's say, let me tell like this here. Okay, this is my sender end, this is my application layer, this is my transport layer. Okay, transport layer is ultimately going to send the packet. So now my application layer is generating, this is my MSS one, my MSS is 1 KB set. Okay, my application is generating 4 KB of data. Now 4 KB of data is sent towards the transport layer. So can anybody tell me how many packets as a result will be sent to the network? How many packets will be sent to the network as a result of it? One packet or more than that? I'm sending a packet of 4 KB, try to understood. I'm sending a packet of 4 KB. My MSS is of 1 KB. In these circumstances, as far as transport layer is concerned, how many packets it is going to generate in the network? Transport, because so packet is going to send in the network by the transport layer, not by the application layer. Application layer is just handing over the transport layer. Transport layer job is to so decide how many packets is going to be. One packet. No. Application layer has generated 1 packet, but transport layer usko divide kar raha hai, 4 packet man send kar raha hai. Now another scenario. Let's say, so now application layer is generating 2 packets. 1 packet of 500 KB, sorry, 1 packet of 500 bytes, another packet of 500 bytes. Application network. So receiver may receive. So whenever receiver is going to receive, they are going to receive as 4 packets. But sender originally कितना packet send किया था? 1 packet. Receiver is receiving them as 4 packets. Now second scenario में, so originally sender application layer में कितना packet send किया था? 2 packets. यहाँ पर so जब मैं भेज रहा हूँ ना, so network में it is not in terms of packet, okay, it is in terms of so bytes. Some bytes of data is going. I don't know whether it is 1 packet, 2 packet, 3 packet. I don't know. Okay, it is just a stream of bytes. So that's why TCP is stream oriented or byte oriented, not packet oriented. Everybody understood why the